Thank you, everyone, and thank you for coming. I know this talk is standing between you and drinks and dinner and all the other things that are planned, so I thoroughly appreciate it. As during the introduction, part of the official reason for me to being here is in my role at Connecticut, I'm fortunate with working with some of the largest enterprises in the world to help them on their journey of using data to help reinvent their business. The unofficial reason I'm here is because I was a math major in college, and I used to be made fun of by my friends who said, this is the most useless major you can ever have. You're either going to be an actuary or a quant on Wall Street, or like you're going to be poor your whole life. And I actually went and declared a computer science major because I was like, well, I should probably get a job that pays well and does something meaningful. And part of my reason being here is I can actually go back to those friends and say, you see, all of you are out there trying to study math and figure out what this data science thing is all about, which I still believe is mostly math. But without taking you back to the whole history, that diversion, if we just go back to 2011, and we all remember Mark Andreessen saying, software is eating the world. And at that point, what he meant was that every company in the world had to become a technology company to be successful. And it kind of doesn't feel that long ago, but Uber was not that big. Airbnb had not reinvented the hospitality industry yet. Those were actually both reasonably small companies in their footprint. And if we fast forward to 2019, now the conversation is around AI is eating the world. And AI is not really new. A lot of the algorithms and research have been studied since the 50s, or there's a long progression of research in artificial intelligence. What's different is we now have the data and we now have the compute to actually utilize those methods to actually extract insights from the data and help drive how we make business decisions. And of course, now the imperative on everybody in every industry is how do we leverage AI to make our business better? As consumers, we all live in the world where it's leading edge technology. Uber, Alexa, Siri, all of that is surrounding our real world. A lot of times when I try to imagine what the world is going to be, I look at my kids who have grown up in the recent technology-enabled era. And I overheard one of my kids talking to Siri and saying, Siri, why are you so stupid? Every single day, I ask you, when is the Giants game? And you keep asking me whether it's the New York Giants or the San Francisco Giants. I live in San Francisco. We talk about baseball every single day. Why don't you remember? Or, my 4-year-old asked me, we are probably one of the biggest users of Instacart in San Francisco. And he asked me, why doesn't Instacart know that we ran out of apples? His expectation is that he has a relationship with this vendor and that Instacart should know that we ran out of apples because we've been a customer for his entire life. And so, of course, back to the payback of my friends that didn't believe it, every company in the world is now in a rush to hire data scientists. Who would have thought that data scientist was going to be coined by Harvard Business Review, nothing less, as the sexiest job of the 21st century? Or there is a data science shortage, and it's ranked one of the top jobs by Glassdoor, or actually, I think, #1. But the key question is, as people go out and hire all these data scientists, the unfortunate truth is that most of the projects actually never make it into production. And the numbers vary, and you see the research, and some are more optimistic and some are more pessimistic. But anecdotally, this one resonated the most as it reflects actually some of my own experience working with some of the largest enterprises, that over 78% of data science projects stall before they get to deployment. And the reasons vary wildly. Some could be that it was never aligned with the business in the first place. Some organizations are so conservative and worried about bias and audit and governance that they are not ready to pull the trigger. Others simply don't have the skill set to figure out how to get it into production. And of course, the press sometimes doesn't necessarily help you, right? Because, there's a lot of concern around, well, Uber's self-driving car, did AI fail us? Or the famous Microsoft chatbot that went from the nicest bot in the world to complete Nazi in less than 24 hours. Or, the little dollhouse is really not a parallel thing, but Alexa ordering things on Amazon, usually I'm used to my kids ordering on Amazon, but Alexa ordering on Amazon based on what it heard on TV. It had no idea that it was actually a TV speaking. It actually went ahead. Amazon and Uber and Microsoft can survive those types of things. But a lot of regular businesses are thinking, what is the reputation damage if something like this happens with the product or something that I roll out? And of course, bias also doesn't help. Right? I think one of the some of the famous and more prescriptive things is in New Orleans, the police assistance and using AI to help police make better decisions, they found that it was actually perpetuating the same biases that police already had within that area, because they trained those models on the data that was there without correcting for the bias that was inherent in the system. Similarly, face recognition. And by and large, a lot of those systems are great at detecting faces of white males. But if you show them Oprah Winfrey, it says it's likely a male. You even show famous people that stand out from that stereotype, deviate from that stereotype, and those models get confused. And most people, don't yet have a formalized approach for how do they develop, assess AI bias, and people worry about the tools and the skills to get AI in production. So part of it is an imperative in this world of AI software eating the world. And the other thing is people are not really maximizing the impact, and there's a lot of concern. So the question is why, right? What is different about this domain than the previous generation, the previous wave that we had? And this will sound a little bit obvious, but traditional programming is you give it input, you apply a program, and you get an output. That program was developed by an engineer through, they've pre-thought scenarios. And they applied logic to say, if this happens, do this. Right? And if you apply the same input, by and large, you're going to get the same output and a lot of predictability into that process. Machine learning turns that equation on its head. You actually feed it input and output, and out comes the program. And the program is dependent on the inputs and the outputs that you fed into those models. Well, a lot of the times you may feed the same inputs and you may not get the same outputs in the real world as you're inferencing, depending on what you train the data on, what this model has seen, and how it's evolved, how the patterns in your data have evolved over time. So what we've kind of done, a lot of us have been part of this software development innovation wave, is we've optimized the software development lifecycle for releasing code. We, by this point, by and large, know really, really well how to release and edit and evolve code in our applications. As you look at the software development lifecycle, it's all about focused on planning, analysis, design. Guess what? There's no mention of data. Data is not part of it because we think of it as we develop, and then we hand it over to the operations and maintenance team to maintain that software. We think of testing as something that happens beforehand. And once you've completed the testing, it's ready to interact with the real world. Similarly, when you look about the roles, in most organizations, and a lot of us have built software, the roles are pretty well defined. And you know which roles are critical at which part in the process, on the continuum between the business analysts and product people and engineers, QA, maintenance, et cetera. But the problem with this picture, that this new wave and the new challenge is around data. And we have to figure out a way we incorporate data, we evolve those processes to account for data. So this whole domain is not that scary, and we have a much better betting average to actually get these things out into production and make them successful. So, for the rest of this presentation, I'd love to share just a few thoughts from what we see with some of the world's largest customers, and what are some of the patterns that we see on that journey of helping bring AI out of the lab and into production. And the companies that we see do this really well focus on 3 areas. They focus on people, processes, and platforms. And it really starts with the people first. If you don't have the right people and the right structures, you may have the best processes, and God knows you have a dime a dozen tools, but you will still not get the right outcome. So I was just in Australia last week and meeting with some of the largest organizations there, and it was interesting talking to companies. A few conversations like, we have the best data scientists in the country, one leader said. And they're so bright, they all have PhDs in math and physics. They're uncovering these insights, but we haven't released any of the things they've done. And part of it, what they were doing, is they had data scientists working in isolation as part of the innovation initiative. And then the onus was on the data scientists to go shop their ideas around to see which business unit wants to integrate it into their application roadmap. Well, as the previous talk was suggesting, first of all, data scientists are not necessarily the best skill that go evangelize and sell it to the rest of the business, but it's also not their job. And so what we see a lot of customers moving to, or companies moving to, is embedding data scientists into those broader line of business or application teams, where you actually don't have one title with the word data in it. You usually have 2. You have the data scientist and a data engineer that have a seat at the table with the product managers, with the engineers, with the quality assurance team, and have the conversation about the business problem. Because then it's a symbiosis that goes both ways, right? The product managers and the engineers can educate the data scientists about the types of innovations they can bring, and the data scientists can actually educate them about the data, about the parameters of that data, and what it means to figure out if something is actually working. When you look at the life cycle of machine learning models, it actually doesn't follow, even in its own, before you bring it to the rest of the software development, it doesn't follow the standard paradigm that we have. There's a lot of learning and experimentation has to be built into this process. So first you build the model, then you deploy the model, and it starts doing something, and it starts making predictions. But the key 2 steps that are different when you apply it to this domain is the continuous evaluation and then the adjustment of the model. So making sure you pick the right metrics to evaluate how well the model is doing and actually focus on that continuous improvement into the application is really, really important. So what a lot of the companies that we're seeing do is actually now formally incorporating machine learning into the software development lifecycle. And there's probably 3 main areas where it differs. Number 1 is the testing. How do you test machine learning models versus standard code? There's a lot of conversations that have to happen in order to understand how do you test it. And the key point is you don't test it just up front. You test it all the time. And what are the metrics that are the right proxies to actually know whether the models are performing the way they're expected? The second thing is, many of us have done code reviews. You go in and there's a committee before you check in your code. Oh, every engineer in the world loves those. Not really. But you go through the code reviews, and now people are introducing model reviews. how do you actually review the model? You don't just look at the Jupyter Notebook and say, okay, check mark, the model is approved. You have to actually understand the data. You have to understand, was the right data used? And where we see a lot of people that are further ahead in the adoption, they're actually incorporating the ethics conversation into this part of the process, where they're coming in and bringing in the beliefs about their customer base, the beliefs around how they do business, and actually starting to evolve to checklists of assumptions and things that they can test to evaluate whether this model can actually go into production. We've seen one of the innovative technology healthcare companies do this very effectively, where they had to educate both their developers and QA and product managers about data and built in very specific steps into the approval process and the checklist to make sure they go through the proper model review. And then, of course, the most important thing is continuous measurement. The only way you know that it's working is if you're measuring it. And having the foundation to actually collect the data and measure data becomes really, really important. So the last but not least is the technology. And when I say platform, it doesn't mean you select one thing that solves all your problem. It's a set of tools and considerations that deliver value. A lot of times we come and we have conversations, and I hear people say, we just got a GPU farm. What should I deploy on it? My answer to that is usually nothing. Until you know what problems you're trying to solve and what your criteria is, you should deploy nothing. Because the problem is you can't have technology, ahead of the solution. Part of it is understanding what are you trying to optimize for, and then there's always a myriad of things that can help solve that. But the three areas that I see as people kind of prioritize and focus that are successful with this is one is democratize data access, focus on the rapid application development. Today, if you have a data scientist, your data scientist develop the model. To get to hello world of actually integrating it into an application in a way we talked about, that you can then measure and test and scale, is actually really, really hard. And so focusing on making it easy, because developers and the broader organization will embrace data science and embrace machine learning faster if you have the tools that actually make it easy for them. And last but not least, data governance. I'm sure there's going to be a lot of talk here around regulation, and some of it is already here, but many of us intuitively believe, and from living in the world, we know that a lot is more to come. And there are some companies that are well prepared to deal with regulation, like maybe, and data governance, like financial services that have had, or pharmaceuticals that have had the expectations and have built the processes over the years. But everybody else will have to be at least prepared to understand that something like this will be coming. So, democratizing data access is about, so many people we talk to, they're like, well, yeah, my data science is doing really well. I've just extracted some CSV snippet of data to them, and they're working on their machine, and they're going to, figure it out. Or, some are saying, well, actually, there's data scientists in this division and in that division, and they're working on different data. And I intuitively know that if they worked on a superset of data, they'd both come up with better solutions, like in different divisions of a transport company, but we don't know how to make that happen. So, too bad, they're working on the slices. So that ability to analyze data at scale becomes really, really important. And what we're seeing is companies that are investing in those type of tools and giving their data scientists access to as much of the entire corpus of data as they have. In many cases, it's also not just their data, but it's also external data sources that they're able to let them blend and extract insights from, the better outcomes they get early on. Right? Because remember, in that equation, your models are only as good as your data. Junk in, junk out. So this is an example of a telecommunications company that really wanted to analyze and build models around how their infrastructure investments were affecting their high-priority, high-revenue customers. And what they were finding that for data scientists to do any level of experimentation, they were going street by street, and maybe in some cases neighborhood by neighborhood, to explore the data. But when they actually gave them the tools to explore the data and slice and dice the data across their entire network coverage, they saw a much higher degree of accuracy. It's kind of obvious, but it's investing in those tools up front and knowing that it's not all magic. There is a very intelligent set of people that you're paying a lot of money to, that if you give them more data and better tools, they'll come up with better insight. The other similar thing is oil and gas company, where here you have in the corner what their data scientists were interacting with before. They had the grainy image of the reservoir, and they were trying to optimize and develop models for the extraction of oil in that reservoir. And when they figured it out to actually give them something that looked like this, I think they went from 9 million records to 90 billion records that they could analyze. All of a sudden, they found is that the accuracy of their models improved tremendously, and also the collaboration within their team, where the geologists could collaborate more effectively with data scientists and help evolve and build better solutions. On the rapid application development, so you have your model, and let's say data science built it, you're kind of confident, you went through the model review. Now to actually integrate it into the application, you have to take the data that's coming in from somewhere and transform it into features that should be usable for that model. That's where the data engineering is incredibly critical. Building those data engineering pipelines that actually satisfy the needs of the application becomes critically important. And then, of course, making those models easily consumable and accessible by developers is equally important as well. So let's take an example. Let's say I have a credit score model. I could build 3 separate applications with it. I can build an identity monitoring application that every time you get a new activity, you actually trigger an alert if my credit score changes. I could build a self-service credit check application where I have a mobile app and I actually click check my credit score, and on demand, it generates a credit score for me. Or I could actually build a monthly credit report application that for all my customers using exact same model is calculating the credit report. What I need to do in order to leverage that model, first of all, I want to make it accessible so the developers building each one of these applications can actually access the model and leverage that model. I also want to make sure that I build the data pipelines. In this case, it's a continuous pipeline, where as the data is coming in, I'm recalculating. In this one, it's probably a web service from the application where I give an on-demand request and it calculates. And this one is a large batch size operation to actually do the calculation for lots of customers. Having efficient data pipelines is critically important to make those applications successful. Now let's say I have those 3 applications, and I, as a customer, call on the company and say, I don't like my credit score. How do they figure out, how does the vendor figure out what application was used for Irina what model, which application was used for Irina to calculate the credit score, and why does she not like it? And so part of the structure that a lot of people that we talk to are starting to put in is, how do I figure out what happened? There's a lot of talk about explainable AI, and I think all of us are going to have to wait quite a bit to reverse engineer neural networks. But what we can do now is actually log the data and understand the data lineage, understand which data was fed into the model, which features were used, and why an outcome was predicted. We can also centralize where those models are deployed so we actually know what's running where and which application is using which version of which model. That at least gives us the ability to say, well, how accurate was this particular model? Or what model was used to predict Irina's credit score, and why did it predict it that way? And how does that compare to other customers within that demographic? And there's a lot of work, I'm personally involved with the World Economic Forum on developing their model AI governance framework. And they're really put together a set of guidelines that companies can self-implement to say, how do I set my organization up for governance around machine learning models? If I haven't, hopefully there's some hope in some of these things. And there's a lot of things we can do. And up next, without kind of a few parting thoughts, is to complicate matters further. In general, a lot of people now are building models themselves. Realistically, my personal belief is that the whole ML space is going to SaaSify. Meaning you're going to consume models as a service or license IP from other people that have better data for that specific problem. And in general, companies are just going to be building models for data, for problems which are their core IP and where they have the best data. But starting to have the conversations with those vendors to say, well, which data did you develop your model on? Is that a representative data set for what I am expecting? Or do I need to retrain some of those models? How do we handle liability if something doesn't work well? So I think there is going to be a set of conversations over the next few years playing out in this whole AI ML as a service space. The other thing is distributed AI. Self-driving cars are kind of the holy grail of artificial intelligence. But what happens when you do something at the edge? You may not have the ability to upload all the data or audit all the data, or you're worried about privacy. So thinking about the applications and thinking about how do you implement the same techniques, but in a distributed architecture, I believe will come much more into the forefront over the next few years. And I think I probably have a minute left to leave on one parting note. While there's a lot of challenges, I personally am very hopeful because I see so many industries starting to actually deliver real impact. Like pharmaceutical companies actually being able to develop drugs faster because they're unleashing their data scientists on all this genomics data and being able to iterate on drug discovery. Or, in telecommunications, the 5G rollout that's going to empower so many new applications that we haven't even dreamed of. There's a lot of iteration and promise and effective usage of those technologies. Thank you very much, and I hope you enjoy the rest of the show.